Hey friends, let's begin with the first example for the chapter number 8 waves. These are unsolved questions from Gujarat board textbook. Now first question is, in case of progressive harmonic waves, prove that the ratio of instantaneous velocity of any particle of the medium, the ratio of instantaneous velocity, that means it is dy by dt, the ratio of instantaneous velocity of any particle of medium to its wave speed is equals to the negative of slope of waveform, that is dy by dx, that we are gonna prove. And now for this, what we need is we need to find out dy by dt first, then we will take a ratio of wave speed and dy by dt. Now for that we are having an equation, y is equals to a sine omega t minus kx. Now take differentiating it with respect to t, we will be getting a cosine of omega t minus kx into d by dt of omega t minus kx, and that will gives you a cos omega t minus kx into omega. So finally we are getting a omega cosine of omega t minus kx, that is our first element of ratio, that is dy by dt. Now we know what is wave speed. Wave speed is always equals to omega by k. We have derived it. Let us derive it once again. That is, we know that phase of any wave is always remains constant. That means omega t minus kx, that always remains constant. So differentiating it with respect to time, now what is differentiation of any constant? That is always 0. Now differentiation of omega t minus differentiation of kx. Here differentiation of omega t will be omega into dt by dt minus of k common dx by dt, that is equals to 0, and we can say omega minus k into dx by dt, that is nothing but change in position with respect to time will give you linear velocity, that is equals to 0. Omega is equals to kv, hence velocity of a wave is always equals to omega by k. Like this we can prove this. Now we are having both elements of our first ratio, that is dy by dt also we have got, that was equals to a omega cosine of omega t minus kx upon wave speed also we have got, that is omega by k. So we can take this k upward, omega cancelled out, and final LHS equation we are getting, that is a cos omega t minus of kx. Now our RHS, that is solution of this, should be equals to a cosine of omega t minus kx. So let us find out minus of dy by dx, and let us see what it gives. We know dy by dx is equals to nothing but differentiation with respect to x of y. What is our y? That is a sine omega t minus kx. Now taking a as a constant out of differentiation, d by dx of sine omega t minus kx will gives you a differentiation of sine theta, that is cos theta, that is cos omega t minus kx, but we also have to differentiate function that is associated with theta, that is this function also should be differentiated. Now after differentiating that function, I'll be getting a cosine of omega t minus kx into d by dx of omega t will be 0 and d by dx of minus kx will be minus k. Hence I'll be getting minus of a into k cosine of omega t minus kx. But what I want, I've already got dy by dx that is equals to this, but I want minus of dy by dx, hence taking minus sign on both the sides, it will become positive and I'll be getting positive ak cosine of omega t minus kx. Now let us compare our these equation with the equation which we have got in LHS, and here they are same. Yes, I forgot to write down k over here. Now they are same because this k will go upward and I'll be getting ak cosine of omega t minus kx, and hence my LHS is equals to RHS, and this is end of our first question. Okay, now let us see the next question. Two types of waves. One is transverse, that is called S wave, and longitudinals, that is a P wave, are produced in the earth during an earthquake. The speed of S wave is approximately 4 km per second, and that of P wave is 8 km per second. In a seismograph always takes readings of these type of waves. It's a kind of instrument which takes readings in terms of like these amplitudes, different amplitudes of waves, which is to measure the intensity of earthquake. Now in this seismograph recording the earthquake, the P wave is recorded 4 minutes earlier than S wave. Assuming that both type of waves travel on a straight line, find the distance of origin of quake from the seismograph. Now suppose seismograph is recording something which is having existence over here, I mean waves of earthquake. Now two waves are produced during earthquake. First is my S wave and second one is my P wave. But here mind well, P wave is having velocity 8 km per second and my S wave is having velocity 4 km per second. So it's but obvious, if I'm standing over here, which wave is reaching first. So here if I'm naming it as S wave and I'm naming it as P wave, my S wave will reach later and my P wave will reach first. So if we talk in terms of time, suppose S wave takes t time to reach over here, then P wave will take less time, but how much less? That is, it was recorded 4 minutes earlier. That means it is taking t minus 4 minutes time less. Hope you are clear with the timing point of view, and the distance that they are covering is same. Let us say this is, I'm talking about d distance, right? So we are having a relation between distance, velocity and time, that is velocity is equals to displacement upon time. As my distance is in a straight line, so it is same as my displacement. Now for the same displacement we are having different velocities. First velocity of s, from this equation we can say that d is equals to vt, so d is equals to vs into ts, and my d also equals to vp into tp. But what is velocity of s wave? We know that velocity of s wave is 4 km per second, it is given, and velocity of p wave is 8 km per second. And here substituting both the values, here note down one thing, LHS are same, here we are having d, here also we are having d, so we can compare both these RHS like this: vs into ts is equals to vp into tp. So from all the above equations, vs we are having 4 km per second, into we have assumed time as t is equals to vp, that is 8 km per second, and time taken is t minus 4 minutes. From here we can get the value of t. Here t is equals to 8 minutes, but let us take in terms of second, so it is 8 times 60, that is equals to 480 seconds. Now substituting value of t in any of this equation, we can get the value of distance. So here let us say my d is equals to vs into t, that is equals to 4 km per second multiply by 480 seconds. So by multiplying this, you are getting an answer 1920 kilometers. So my earthquake epicenter is 1920 kilometer away from me. Thank you. Now next is example 3. So this is our third question. The amplitude of progressive harmonic wave is 10 meter. Amplitude is already given to us, that is 10 meter. During the wave propagation, my wave is propagating, and during its propagation, the displacement of particle which is at a distance of 2 meter from here, at some distance 2 meter, the displacement will becomes, that means x1 is equals to 2 meter. At that time my y1 becomes 5 meter, and my time t1 is equals to 2 second. Another particle which is at a 16 meter from origin, means from here x is equals to 16 meter, that means my x2 is equals to 16 meter, that is my second case. My y2, the displacement of 5 root 3, that means y2 is equals to 5 root 3, and my time t2 is equals to 8 second. Here note down, amplitude remains same for both the cases. Here also amplitude a will be 10 meter, here also amplitude a will be 10 meter. We need to find out angular frequency and wave vector. Now we are having equation of a wave, that is y1 is equals to a sine omega t1 minus k x1. For any wave, omega and k are constants. Here y2 equals a sine omega t2 minus k x2. My y1 is 5 meter, that is equals to amplitude, that is 10 meter, which is constant for both the waves. Here we had noted it down, sine omega t1, that is 2, minus kx1, that is I can say 2x, because my x1 is also 2. Here I can say y2 is 5 root 3, which is equals to 10 sine t2 is my 8 second into omega minus x2k, that is 16 into k. Now taking 5 by 10 equals to sine 2 omega minus we did small mistake. It is k 2k. It is 2k. Here 1 by 2 equals sine 2 omega minus 2k. Now we know that sine of theta is 1 by 2 only if my theta equals 30 degree. That means I can say that 2 omega minus 2k is equals to 30 degree, that is pi by 6. Similarly, here 5 root 3 by 10 equals sine 8 omega minus 16k, and here we can say that root 3 by 2 is equals to sine 8 omega minus 16k. But if theta equals 60 degree, then only sine of theta becomes equals to root 3 by 2. So here I can say that my phase 8 omega minus 16k is equals to pi by 3, that is 60 degree. Now from here we are getting one equation, here we are getting second equation. Now solving both of these equations, we'll be getting, let us make it simple, like omega minus k is equals to pi by 12, and here we can say that omega minus 2k is equals to pi by 24. We have simplified these equations. Now omega minus k equals pi by 12 and omega minus 2k equals pi by 24. Changing signs, this will be cancelled out. K equals pi by 12 minus pi by 24, that will be equals to 2 pi minus pi by 24, that is equals to pi by 24. Simply we have got value of k, that is equals to pi by 24. Now let us find out value of omega. By substituting value of k over here, omega minus pi by 24 is equals to pi by 12. We have just substituted value in this equation. So I can say that omega equals to pi by 12 plus pi by 24, that is equals to into 2 into 2, 2 pi plus pi, that is 3 pi by 24, that is nothing but pi by 8 radian per second. So we have got omega equals to pi by 8 radian per second and k is equals to pi by 24. Oops, it is per meter. So here are our value of omega, that is pi by 8, and value of k, that is pi by 24. Next is fourth question. Now in this question there are two sub questions in it. Equation is given to equation of wave, that is y is equals to, you know that we are having general formula a sine omega t minus of kx. Now comparing this equation which is given to you with our standard equation, just note down one thing: omega t is given over here, that is at a later side, and kx is given in initial side. So interchanging their places will yield minus sign out of bracket. So let us make the necessary changes to make it as a standard equation. We are having y is equals to 3 sine 3.14x minus 314t, but we need to take minus sign out. I'll be getting 3 sine 314t minus 3.14x. As we know, sine of minus theta is minus of sine theta, so I have directly taken negative sign out of the angle. So comparing this equation with the standard equation, we need to find out maximum velocity. For maximum velocity, we need two quantities, that is omega times a. I need omega and I need amplitude. Now what is my amplitude? It is minus 3. Magnitude of this will gives you 3, and omega, from here I can take omega is 314. Omega is equals to 314 radian per second. Now velocity is equals to 314 into 3. That is equals to 942 centimeter per second. Converting it into meter, it will give you 9.42 meter per second. Now why I had taken it as centimeter per second? Because here clearly they had given us x is in centimeter and t is in second. So x is in centimeter and t is in second, and hence my amplitude will also be in centimeter. So my resultant velocity will be in the form of centimeter per second, and converting it into meter per second, I'll be getting velocity equals to this. Now second part of the question asks you to find out acceleration. Acceleration, for that let us see that given you both the values of x and t, that is x is equals to 6 centimeter and t is equals to 0.11 second. Now putting those values in our standard equation of wave, so I'll be getting y equals to minus of 3 sine 314 into time, that is 0.11 second, minus 3.14 into x, and x is given as 6 centimeter. Now we know for acceleration my formula is omega square into y. So let us find out value of y. From here now I can simplify this 314 as 100 times 3.14 into 0.11 minus 3.14 into 6. Now putting 3.14 as pi, I'll be getting minus of 3 sine pi times 100 into 0.1, that is 11, minus 6 pi, that is equals to minus of 3 sine. What is 11 pi minus 6 pi? That is 5 pi. And we know that sine of n pi, any pi, n is equals to 1 pi, 2 pi, 3 pi, 4 pi, 1000 pi, it will always gives you 0. So my y is equals to minus of 3 into 0, that is nothing but 0, and acceleration is equals to omega square into y, and that will also be 0. So acceleration is 0 in your final answer. Next is fifth question. Celsius, temperature. A source of sound of frequency 250 Hz emits sound waves of wavelength 1.32 meter. What will be increase in wavelength at 27 degrees Celsius? That means we need to find out by how much time the wavelength increases when the temperature is increased by 27 degrees Celsius. So for that we need to find out lambda 2 for 27 degrees Celsius if lambda 1 for 0 degrees Celsius is given to you as 1.32 meter, and our frequency is 250 Hz. So let us see the relations. We know that wavelength is related with temperature only through velocity. Let me make it more clear. We are having relation of velocity and temperature as v equals to root of gamma rt by m. This we have derived after Laplace correction. And relation of velocity with lambda is v is equals to f lambda. So we will be comparing velocity are common. We can make these two comparisons of f lambda with gamma rt by m. Now if I changes temperature, let us say mass is constant, r is constant, gamma is constant. If I change the temperature for temperature 1, I can say that my V1 is proportional to root of temperature 1 and my V2 is proportional to root of temperature 2. From here I can get one ratio V1 upon V2 is equals to root of T1 upon T2. That is the simple ratio. From here, if my V1 is equals to f lambda 1 and my V2 is equals to f lambda 2, I can get relation as V1 upon V2 is equals to lambda 1 upon lambda 2. Now, comparing these two equations, I can say that lambda 1 upon lambda 2 is equals to root of T1 upon T2. And from here, I can easily get the value of lambda 2, that is equals to root of T2 upon T1 into lambda 1, that is equals to root of temperature T2 is already given to me as 27 degrees Celsius. Let us convert it into Kelvin, that is 300 Kelvin, and my temperature T1 is 0 degrees Celsius, that is equals to 273 Kelvin. Now 300 upon 273 multiply by lambda 1. Lambda 1 is already given to me, that is 1.32 meter. Yes, and multiplying it over here, I'll be getting lambda 2. So for further calculation, my lambda 2 will be equals to 1.38 meter. Read carefully what they have asked us. This is that what will be increase in wavelength. So here it is sure that wavelength is increasing if I am increasing temperature from 1.32, it is becoming 1.38. So what is change? That is lambda 2 minus lambda 1 is equals to change in lambda, and that is 1.38 minus 1.32, that is given as 0.06 meter, and that is our final answer. Next question. In this question, we need to find out at what temperature the hydrogen gas will have the speed of sound waves in it will be equal to the speed of sound in oxygen at 1200 degrees Celsius. It is given to you that density of oxygen, it is given that density of oxygen is 16 times density of hydrogen, and the condition is speed of sound wave in hydrogen should be equals to the speed of sound in oxygen. Velocity in hydrogen should be equals to velocity in oxygen. Now formula of velocity that we have is equals to root of gamma rt by rho v. Now for hydrogen I'll be having Vh equals root of gamma r th upon rho h into v, and for oxygen I have root of gamma r TO upon rho O into V. But it is already given that density of oxygen is 16 times that of density of hydrogen. Substituting this condition, I'll be getting 16 rho H into V. Now comparing VH and VO as it is given in the question, velocity of hydrogen should be equals to velocity in oxygen. So comparing both these values, my this value and this value, I'll be getting root of gamma R temperature in hydrogen upon H into V should be equals to root of gamma R now squaring on both the sides. I'll be getting gamma R TH upon rho H times V equals to gamma R TO upon 16 rho H times V. Now cancelling out the common terms, I'll be getting TH equals TO upon 16. But temperature of oxygen is given to you, that is 1200 degree centigrade. We need to convert it into Kelvin. It's 273. And we need to find out TH. So TH equals 1200 plus 273 upon 16, that is equals to 92.06 Kelvin. Now again converting this into Celsius, that is equals to minus 273. TH is equals to minus of 180.9 degree centigrade. That means at what temperature hydrogen gas will have the speed of sound waves in it will be equals to speed of sound in oxygen at 1200 degree Celsius. Means speed of sound and in oxygen hydrogen will be same if hydrogen is at temperature minus 180.9 degree centigrade and oxygen is at temperature 1200 degree centigrade. So there is a huge difference between them. Now next question is 7th question. This question, the length of sonometer wire between its fixed end is 110 centimeter. The sonometer wire is between two fixed ends. Let us say this is my straight wire between two fixed ends. Let's denote this as fixed ends. Is 110 centimeter. This distance is already given to you, that is 110 centimeter. Now where should the two bridges S1 and S2 be placed in between the ends so as to divide the wire into three fragments whose fundamental frequencies are F1 is to F2 is to F3 is equals to 1 is to 2 is to 3. Means we are gonna divide this wire into three segments like this, and their fundamental frequencies should be such that, what do you mean by fundamental frequencies? Means these frequencies for length L2 and these frequency for length L3. So this is my length L1, this is my length L2, and this is my length L3. We need to find out what will be these lengths, but we are having one equation, that is L1 plus L2 plus L3 will sums up to 110 centimeter. And one more relation is given to you, f1 is to f2 is to f3 is equals to 1 is to 2 is to 3. Now one more thing that should be crystal clear in your mind is that velocity of all these waves on these stretched string will be same, because for all these three waves we are having same medium, that is a string with some tension t, right? Now I can say that if their velocities are same, that means their v1 will be equals to v2 will be equals to v3. I can say that lambda 1 f1 will be same as lambda 2 f2 will be same as lambda 3 f3. But I'm not interested in lambda, I am interested in lengths. So there are one relation between lambda and lengths, that is lambda n is equals to 2l by n, and here all the fundamental frequencies are there. So for my wavelength and for fundamental frequencies, n is always equals to 1. So for my lambda 1 it is equals to 2l1, my lambda 2 is equals to 2l2, and my lambda 3 is equals to 3l3. That we can also easily see from here. See, l1 is having half of the length of lambda, so for full wave I'll be having 2 times l1. So it is clear from figure also, right? Oops, small mistake here, also it will be 2 lambda 2 into l3, right? Because here also it will be completing full wave if my length is repeating for 2 times. Now substituting that values over here, I'll be having 2 into l1 f1 is equals to 2 into l2 f2 is equals to 2 into l3 f3. Now let us compare these two. If 2l1 f1 is equals to 2l2 f2, 2 cancelled out, l1 upon l2 is equals to f2 upon f1, but I'm already having an equation f1 is to f2 is to f3 is equals to 1 is to 2 is to 3. So f1 upon f2 is equals to 1 upon 2, or f2 upon s1 is f1 is 2 upon 1. So l1 upon l2 is f2 upon f1, that is equals to 2 is to 1. So I'm having one relation of l1 in terms of l2. So I can say that my l2 equals to l1 by 2. This is one equation which I have brought of l2 in terms of l1. Now my strategy is simple. What I'll be doing is, I'm having this standard equation, so I'll be finding out L2 in terms of L1, L3 in terms of L1, and substituting in this equation I'll be getting value of L1. So thereafter it will be very easy to find out other values of L2 and L3. So now I'll be comparing these two now, right? Comparing these two, what I'll be getting is 2L2 into F2 is equals to 2L3 into F3. Oops, we did a mistake. We are not gonna compare these two. As I told you, we have to bring every result in terms of L1. So we are comparing these two. Now from this, 2L1 F1 is equals to 2L3 F3. So 2 will be cancelled out. L1 upon L3 is equals to F3 upon F1. And you know that F3 upon F1 is 3 upon 1, or we can say that L1 upon L3 is equals to 3 upon 1, So my L3 is equals to L1 by 3. Now substituting all the values in our standard relation, that is L1 plus L2 plus L3 is equals to 110 centimeter. So L1 plus L1 by 2 plus L1 by 3 is equals to 110 centimeter. So 6L1 plus 3L1 plus 2L1 is equals to 660 centimeter. I'll be getting 6 plus 11 L1 is equals to 660 centimeter. L1 is equals to 660 by 11 centimeter, that is equals to 60 centimeter. Now substituting L1 in L2 is equals to, we had seen L2 is equals to L1 by 2, L3 is equals to L1 by 3. So my L2 is equals to L1 by 2 and my L3 is equals to L1 by 3, that is equals to 60 by 2, that is equals to 60 by 3, and I'll be getting 30 and I'll be getting 20 centimeter. So my all three lengths I have got L1 equals to 60 centimeter, L2 is equals to 30 centimeter, and L3 is equals to 20 centimeter. Now this is 8th question. A wire having a linear mass density, that means here mu is given to us, that is 0.05 gram per centimeter, is stretched between two rigid support with a tension of 450 Newton. Tension is given as 450 Newton. The wire resonates at a frequency of 450 Hz. The wire resonates at a frequency of 420 Hz. The next higher frequency at which the same wire resonates is 490 Hz. So here we are talking about harmonics. 420 Hz is nth harmonic. Right, that is given as Fn to you. And next higher frequency, that means Fn plus 1, that is given as 490 Hz. Hope this is clear. And Fn and Fn plus 1 has a relation with a fundamental frequency, and that is given as Fn is equals to n into fundamental frequency, n times fundamental frequency. That is, if it is Fn plus 1, that means n plus 1 times fundamental frequency, right? So instead of Fn, I can write down nF1. Instead of Fn plus 1, I can write down n plus 1 F1. Right, now taking ratio, nF1 upon n plus 1 F1 is equals to 420 upon 490. Here I can say that n upon n plus 1 is equals to 42 upon 49, or I can say that is equals to 6 by 7. So my n is equals to 6. I've got it. N is equals to 6. Now what they have asked, find the length of wire. Now what is the relation between length and frequency? The relation is very clear. Fn is equals to nv by 2l, and this v is velocity. But here velocity is not given directly to us. Velocity is given in terms of velocity. We have to find out in terms of mu and t. It's very simple relation that we have derived. Velocity was equals to root of tension upon mu. Now substituting this value in this equation, I can easily get the value of L. See, if we are taking n is equals to 6, that means my frequency will be 420 hertz. If you are taking n equals to 7, that means you have to take frequency as 490 hertz. So that should be associated with n. I'll be taking 6. So what I need is L. So I'll make L as a subject. So L is equals to NV by 2 Fn, or I can say that that is equals to N by 2 Fn into root of T by mu. Now substituting all the values, I'll be getting that is equals to, I'll be taking N is equals to 6 upon 2 into 420 hertz into root of tension is given to me as 450 upon mu is given to me as 0.05 gram per centimeter, that is equals to 5 into 10 raised to minus 3. I have converted it in terms of meter. Now putting all the values and calculating, you'll be getting value as 2.1428 meter, which can be approximated as 2.1 meter. See, this conversion for gram per meter, gram per centimeter, it can easily be done as kg per meter, and for your convenience I am solving it over here. 0.05 gram per centimeter is equals to 0.05 into 10 raised to minus 3 kg upon for centimeter, converting into meter, it is 1 into 10 to the power minus 2. So finally we'll be getting 0.005, that is 5 into 10 to the power minus 3. Now this is ninth question. This ninth question, the question is such that the length of a string is given to you. That means L is with us, that is 100 centimeter. The frequencies of two consecutive harmonics, it is same as question number 8. That means frequencies of two consecutive harmonics Fn and Fn plus 1 is given to you, that are 300 hertz and 400 hertz respectively. The maximum amplitude is 10 centimeter when the string oscillates with its fundamental frequency. See, they had given you that it oscillates with fundamental frequency. Write the equation of stationary wave in this case. See, general equation of stationary wave we already have. Y is equals to minus 2a sine kx cos omega t. Now what we need to find out is omega and k to make it a complete equation. Now maximum amplitude is already given to you, that is minus 2a, which is already given to you, that is 10 centimeter. So 2a magnitude is 10 centimeter given to you. Now I'm interested in omega and k. Now for that, fundamental frequency f1 should be with me, because I need to find out this at fundamental frequency f1. Now what is the relation between fn and f1? I'd shown you in example 8 that Fn is equals to n into F1 and Fn plus 1 is equals to n plus 1 into F1. Now this is given as 300 and this is given as 400. Now taking difference of this, I can say that n plus 1 into F1 minus n into F1 is equals to 400 minus 300. My goal is to find out F1. So nF1 plus F1 minus nF1 is equals to 100. So my F1 is equals to 100 Hertz. Now I know that omega is equals to 2 pi f, that is 2 pi f1, which is equals to 2 pi into 100. So my omega is equals to 200 pi. I have got omega. Now my goal is to find out k. K is equals to 2 pi by lambda. Now I am having length, and I know that L is equals to lambda by 2, or we can say n lambda by 2. For fundamental frequency n equals to 1, so it is simply lambda by 2. So my lambda is equals to 2L, and that is equals to 2 into L. I think length is given to us, that is 100 centimeter, and putting that value I'll be getting lambda equals to 200. Now keeping all the values over here, I'll be getting k equals to 2 pi by 200, that is equals to pi by 100. Now I have got k, I have got omega. Putting these values in our standard equation, that is minus 2a sine kx cos omega t, that is equals to minus of 2a. Now maximum amplitude is given as 10 sine pi by 100, that is value of k, into x cosine, we are having value of omega as 200 pi, that is 200 pi t. This is my equation for resultant wave when it is oscillating at fundamental frequency. Now 10th question is, find the difference of apparent frequency of sound of a car horn heard by a stationary listener when car is moving towards and away from the listener. See, there are two cases. In the first case, let us draw our axis. I'm having two cases. My source should always be in the first quadrant. And my listener should be in the second quadrant. First condition is my source is moving towards listener, hence it is approaching minus x direction. It is plus x direction, it is minus x direction, it is plus x direction. And my source is approaching my listener, that means it is always approaching negative x-axis, hence my velocity will be minus of vs. My listener is stationary, hence VL equals to 0. My listener is stationary, hence VL equals to 0. and my source is moving away from the listener. At that time, my Vs is approaching positive x-axis and it is plus Vs. Now velocity is given as 54 km per hour, and that should be converted into meter per second before placing it. Hence 54 km per hour is equals to 54 into 10 raised to 3 divided by 3600, and that is equals to 15 meter per second. Now here it is moving 15 meter per second away, and it is 15 meter per second towards. Now our general equation is frequency heard by listener is equals to velocity in medium plus or minus VL, velocity of listener, upon V plus or minus velocity of source into frequency of source. And frequency of source is already given to you, that is equals to 500 Hertz. Velocity is given to you, that is equals to 340 meter per second, that is velocity in a medium. Now for two different cases, for these cases we are having FL equals to V upon V minus Vs into Fs, and for this case we have FL equals to V upon V plus Vs into Fs. Now substituting the values here, that should be green color, FL equals to 340 upon 340 minus 15 into frequency, that is 500 Hertz, and that will give you 523 Hertz. Let us give it frequency 1, and here FL is equals to 340 upon 340 plus 15 into 500, that will gives you F2, that is equals to 478.87. Now taking differences, F1 minus F2 will be equals to 523 minus 478.87, that will give you 44.2 Hertz. Now this is 11th question. The whistle of engine approaching a hill with a speed of 10 meter per second produces sound of frequency 660 Hertz. That means frequency of source is given to you. Oops. Frequency of source is given to you, that is 660 Hertz. Find the frequency experienced by the driver of the sound reflected from the hill. Speed of sound in air, that is V, given to you 340 meter per second, and velocity of source is also given to you, that is 10 meter per second. But mind well, whatever the velocity of source is, that means if my engine is producing some sound, and if that sound is reflected by the hill, it will be of the same velocity as of my velocity of engine. That means here listener will not be a stationary, here listener is also moving. So here the secondary source is also not stationary. We can understand this as a case of moving source and moving listener. or we can say that listener is approaching source and source is approaching listener. It can be the case of this, but in both the cases velocity of listener here it will be plus 10 because it is moving over here, and velocity of source is minus 10 because it is approaching. Vs is equals to minus 10 meter per second as it is approaching our positive x direction. Now it can be the case of moving source and moving listener. So my FL is equals to V plus VL upon V minus Vs into Fs, that is equals to 340 plus 10 upon 340 minus 10 into 660. By solving it, you will get 350 upon 330 into 660, that is equals to 700 hertz. This can also be solved by taking separately. First take these as a source and mountain as a stationary, then take mountain the reflected wave as a source and driver as a moving, but this will be quite lengthy. You will get the same answer which you are getting in this case. So this was the last sum. Thanks for listening.